Welcome to the Standardizing Change IEEE P2675 DevOps Standard. My name is Ruth Lennon. So who am I and why am I here to talk about DevOps? I work for a company called Crave Technology Consulting. I also do an awful lot of work on standards. So the one we're here to talk about today, I suppose, is the IEEE P2675, which is the standard for DevOps. But I also work on other standards. I work for the ISO IEC JTC1 AG3, which is on open source, the JTC1 subcommittee 38, which is on cloud computing and distributed platforms. I'm the coordination liaison for group JTC1 SE7, which is the software engineering group within, but the liaison to cloud computing. I am on the ad hoc group 1 and I'm on the SCO2 software engineering. Those are the ISO groups that I'm involved in. I'm in the IEEE, as I said. I'm also the ACM. I get a lot involved in standards as much as I can because I think they're really important. And on the side, I also work as a lecturer in Letterkenny IT. So we all hate standards. There are too many standards out there. There's too much to choose from. And sometimes they seem to contradict each other. They're often out of date by the time you get around to getting hold of one. And let's face it, they're expensive. There are all good reasons why we want to hate standards. And we do. We all hate them because they force us to do our job in a different way. And that's not good. Or at least that's the thinking. And I think rather than saying we hate standards, we should look at it differently and say we need standards. So let's go back to our arguments. There are too many standards to choose from. Well, stop trying to do it all at once. Don't try and take on all the standards you think you need for your project, whatever project it is you're working on at any given time. Don't do it all at once. Standards will work together if they're created correctly. So if you're following a good standards, there shouldn't be any issue whatsoever. Standards sometimes contradict each other. Well, if that's the case, you're probably looking at a wrong version of a standard. Maybe it's an old version of a standard, or maybe you're looking at different groups. Maybe you're looking at something that's not actually a standard at all. Maybe it's some form of guidelines from a particular company, and they want you to use their particular products or tools. Generally speaking, the ISO bodies or similar, NSAI, IEEE, ACM, it doesn't matter, whichever they are, they look at the standards that they've got in existence and they say, we don't allow a new standard to come along that contradicts earlier standards unless there is an exceedingly big shift, big change. And then you have to justify to within an inch of your life as to why that standard requires contradiction with an existing standard. What is so truly different? And 99 times out of 100, you're going to find out that they don't contradict. They shouldn't have to contradict. They can work together. There was the argument that the standards are often out of date by the time you get them. Well, again, they shouldn't be out of date if they're well written. Standards generally cover what needs to be done rather than the how it needs to be done. So for example, if I'm writing a standard and it's on encryption protocols, whatever I write on my standard, and it can take 2 to maybe a little more years to write a standard. Well, I know by the time that time is up, encryption standards you hope will have pushed on a bit, or not standards, encryption techniques will have pushed on a bit. So instead we talk about why we want it done and where we apply it and what are the general practices that you should do, rather than the very specific X number of bits need to be applied here, here, and here. That's just not in a standard and should not be in a standard. Then the next argument was that standards are expensive. Yeah, they are. I would love to make them free. I don't run the standards boards. If I did, things might be different. Standards are expensive. Last time I looked, there were about 180 or 190 euro for a standard. And then you need, well, should apply multiple standards. Standards aren't often targeted at the one-man business, and they should be. How can you get a starting point on this unless we begin from our small business? And then by the time the company expands and raises, of course, those standards will become second nature to them. Standards are expensive, I'll grant you that one. So let's look at some standards then. What kind of standards might you apply in software? Now, there are lots to choose from, I agree, but each has their own domain. Each has a specific purpose as to why they're there. And if we look at that purpose and focus solely on that purpose, maybe we'll get a better understanding of why we need to look at that one, how to apply it. So I've taken a couple of examples that I think might be better known examples. So the IEEE 12207 covers the software lifecycle process. It covers the end-to-end from requirements right down to the product delivery. The 29119 focuses strongly on software testing. You've got the Square standards, which is the ISO IEC 2500 standards. We're going to go into each of these in a minute, but it covers generally quality. How do we apply quality to our product? And just taking one more example, security. 27034, I'm looking at part 1 for application security. Those are example standards that we could apply to our software development practices. Again, there are other standards. That other box there is to represent that there are other standards that we could apply. But I'm going to talk about a few that are here. So let's begin with the first one, 12207. That is a standard referring to specifically systems and software engineering, and the part that we look at is the software lifecycle processes. Now, you can argue whether you're a waterfall fan or if you're an iterative fan, whether you prefer Agile or whether you like XP, it doesn't matter. The point being, there has to be some sort of structure to it. We have that structure. We need to know what kind of things should we think about when we're creating that structure. So 12207 very loosely covers task planning, project assessment and control, decision management, risk management, configuration management, information management, measurement, and quality assurance. Now, when you look at those, they seem to cover everything. But then you go into it again and think, right, where's continuous integration? Where's automation? Where is and on and on? So this is a slightly older standard, but it's very popular. It's still in there. And you can't see anything that has directly usurped it yet. Give it about a month. So for now, the 12207 standard is the standard with regard to software lifecycle processes. It begins from the task planning to think about how you're going to develop the software. It's not just a straightforward task. You're going to have to look at assessing the project in part of your plans, your decision management. How are decisions being made? How do you justify those decisions? Where do I find out about those decisions? What risk management is covered? Now, I think there needs to be a bit more on that, but that's a personal opinion. Configuration management. It's quite narrow in 12207, and that's fine. It was built for a specific purpose. Information management is there. We need to not lose that knowledge that we have gained as part of this development process. And then there is a quality assurance. Now, when we look at quality assurance in the 12207, we have to remember that the Square standards are still there. They haven't gone away. In fact, this says that you should apply quality assurance. In fact, we'd recommend you apply it here, here, and here, but it doesn't say the how. So that brings me obviously to my next standard, which is the ISO IEC 2500, which is kind of more formally known as the Square standards. Now, if you look at these standards, if you're not familiar with them, what we end up with is 2501, 2502, 2503, 2504. And those are the 4 divisions of our standards. The first division covering quality models, the second division covering quality measurement, the third covering quality requirements, and then the last covering quality evaluation. It covers all of those aspects to bring to you the quality management division. Now, each standard, as you go to read them, they're actually quite long. They can be anywhere from 40, 50 pages to a couple of hundred pages. And that doesn't include the annex. Now, the annex to the standards tends to be the more interesting part, because what they do is they take a use case and say, how do you apply this standard? How do you put this into practice? What might it look like for an organization in a, for example, financial arena? a small organization in the financial arena, what would they need to consider when they look at quality? So do make sure to go through the annex as you get them. So that is, of course, the 2500 or square standards. Now let's look at the 29119. This is a testing standard. Now there were precursor testing standards to this, but this is the one I'm going to focus on as being a more relevant standard to us. This again is software and systems engineering, but the focus this time is on software testing. And it covers test processes, test documentation, and then test techniques. So let's go through it. So in the test design, we need to worry about how we design our tests. What kind of specifications do we have for our tests? Is there a specific procedure set out for those tests? And if not, why not? Basically, there should be. What are the test data that we're going to use? Where are we getting that test data from? How is it laid out? How do we keep control on that data? Where do we hold a copy of it so that we don't hold it more than once? But we do need a copy of it. Test data readiness. We need to talk about reports to say that, yep, we can use this. When can we use this data? How do we use this data? What is not okay to use? We need to set up a test environment. And in our test environment, we are going to decide that our structure for our test environment must replicate the production environment as much as possible. So again, we do readiness reports to say how far we're getting along, does it match, so that when we do our tests, we can say that our tests are validating as they should do. So test techniques. Some of the test techniques that are covered in 29119 include equivalence partitioning, classification tree models, boundary value analysis, syntax testing, combinational techniques, decision table testing, and on and on. So it gives a good variety. Now you notice in each of these, say for example, classification tree methods, we can go down further and give the specifics of that, but that's not what the standard's about. It's about how do you apply the processes and what kinds of processes you should apply. In truth, what we're looking at is the fact that if we want to increase the quality here, we have to apply more tests. More tests take more time. The more time we spend on this testing phase, of course, we're going to end up increasing the cost because it's the cost of the people involved in the testing, and then it's the cost of delaying the product going out. But that's not actually what the 29119 standard says. It doesn't say to do the testing at a specific time. It tells you how to do the testing. So I mentioned another example because I think we get rigid in what we're doing. So let's look at a security example. So we've got 27034, and I'm looking at section 1, which is the application security. And it defines a number of items. I'm not going to go through them in detail. I do strongly recommend the Security Compass website. They have a great explanation of this, which is a really lightweight introduction as to what the standard is. But let's just cover a couple of the basics. It defines the application security controls so that you can prevent weaknesses in your application. It gives you a lightweight introduction as to what you should be doing. But those controls apply in different areas, in different domains. So we have levels of trust based on the controls we have and based on the domain in which we're working. That's on a application level, but we also have an organizational level. So we've got an organizational normative framework, ONF, and that decides when we should apply each activity or how we should apply each activity. And then we have the application normative framework, and it refers specifically to the application rather than to the organization in general. So each of these ASCs are relevant to the specific context that they're applied. So you might have ASCs or controls for technical reasons. For what are the technicalities that we need to apply to make sure that we stay safe? Or we may apply these ASCs to conform to legal or other regulatory requirements. So each domain may have a different angle or view that we want to take based on what we're doing. Of course, each of those ASCs that we define can sit within different levels of trust. Now, that's not a simple standard, but it's an important one as well, I think. And you can take elements of it and start to build on standards like this as we go through. But what we're here today for is to look at the DevOps standards. So the IEEE have gotten together to come up with a standard, and it is the draft standard for DevOps to build reliable and secure systems. And this standard includes application build, package, and deployment. Now, I know the ISO are looking at this standard as well. So with any luck, it'll be an ISO, IEC, IEEE standard once it's finalized. The first draft of this standard has already gone out for voting, for balloting, and the ballots have come back. So this should be with you very shortly. So what is the standard about? The standard focuses on establishing effective compliance and effective IT controls to support the process. Some of the basic or guiding principles are, we want to focus on mission first. We want to focus on the customer focus. We talk about left shift, that it's a new mindset. We want to talk about continuous integration, continuous delivery, continuous deployment, continuous everything. And then we talk about systems thinking. Stop thinking about that single path or the single element as we go through. What we're actually talking about is the end-to-end system from conception to retirement. Now, this standard bases itself on the 12207, so it's not contradiction to that. But it does add to it. It says, okay, but in this scenario, this is what you have to do differently. This is what you have to add on, or this is some additional things that you have to think about, or maybe to help you scope what you need to do. We really want to take in stakeholders, allow them to inform the decisions, to give guidance as to what has to be done. And those stakeholders are not only developers, they're not only the clients or operations. They include people like your regulatory bodies, your security. What about HR teams? Hiring the right people to do the job. So they need to be informed of what are the key skills. There's a lot more to it. So DevOps systems and any system that interconnects with them, any systems that are part of them, any constitute systems, they have various stakeholders that we want to be aware of this process, to be a part of the process, so they can inform a more appropriate build to give us a package at the end that will suit the customer needs. So again, let's break up what does the DevOps standard include. The standard is not out yet, so I'm going to tell you what a DevOps standard should include. It should talk about project enabling processes. It should talk about technical management processes, and then the technical processes themselves. So the project enabling may be referred to as simple tasks like lifecycle management, infrastructure management, portfolio management. I mentioned before, HR management. What about knowledge management? What about passing on what you've learned? Because remember, software lives for a lot longer and our teams change. So the fact that you know something, you are the guru in that area, that's no good. You need to make sure that that knowledge is passed on. And how do you do it? What about project planning? So our project planning, our project control process, decision management, risk management. We might have configuration management, information management, and again, then just general measurement of what we're doing. So that brings us then to our technical processes. When we're considering our technical processes, as much as anything else, we need to consider our mission analysis. We need to say, why are we here? Why are we doing this? How does that small task that we're working on, how does it feed back to the original customer request? How does it return value to that customer? So we're going to consider things like the software architecture or the system architecture. We're going to talk about design and analysis. We're going to talk about implementation processes, integration, verification, validation, the transition from one stage to the next or from one version to the next, the operation process. less spoken of is the maintenance process and, of course, the disposal process. So let's look at the first of those. Sorry, I think I jumped a slide. No, I didn't. I just have the wrong number on it. This should be part 1. So at the beginning, we have our mission analysis and stakeholder needs. We've moved through to software requirements, systems requirements. We look at architecture. We look at our design. Then we look at our analysis. We look at our general systems analysis. And then we move on. And I'm just breaking this diagram into 2 pieces for the sake of clarity. So with DevOps, we want greater vision, or we want a greater view into all processes in the system. We want to break down this idea of silos that we would have had before. So in these technical processes, we want to realize that product into something that is efficient. We want to make sure that it's secure. I mentioned both of those, but what I haven't really talked about is that it should be safe and it should be reliable. And in order to do that, we really need to bring in our stakeholders a lot more. And those stakeholders include people that I previously mentioned, including maybe our legal team, our compliance team, our risk, who's involved in assessing that risk or defining the risk. We might have privacy teams to look at data privacy, which of course is quite separate to security. We have operations and then the security themselves. And they're just examples of who we may have, depending on the size of the organization, of course. So here we're looking at a process for establishing and maintaining requirements, from traceability right down to the artifacts being established. And then the artifact generation, how is that done? Are we going to automate any part of the process? Within our design, we look at our design of the individual components or elements. We talk about the design of the architecture over which it lies. We look at correctness, consistency, and completeness within that design. Now, the design itself is going to vary from system to system, so we need to record all that design. So now we move on to our incremental development. How do we implement this system? Now, in order to do that, we are definitely going to have continuous integration. It's important. We do that not just towards the end, but that we continuously integrate, find those problems earlier, and certainly we can solve the issues a lot more cheaply. By doing this as well, we allow for our audit and regulatory sub-processes to be defined early on and to be applied as we go so that we can identify those issues. So we'll define processes or standards for safety, risk management, continuity management. But don't forget performance. We haven't talked about performance yet. So performance obviously is going to have a hit on the system, as is security. So we need to plan for it from the beginning. So it's not enough to just look at it towards the end. So we need to track our baseline. We need to check any branched code, merged code. We need to track these things over time. Again, what may not have been covered in some of the other standards is that we also need to include metadata on this. We need to include information on the environment over which things ran, maybe the dependencies that there, particularly where there are dependencies on other software that you may have downloaded elsewhere, or maybe open source software. Where did it come from? What version were you using? We need to maintain traceability as we go throughout the system, because if we don't have that traceability, then we're not going to be able to understand where these decisions came from and why it was critical to use that piece of software. We try to implement automated notifications of the system changes because we want to know when something has happened, when something has changed. It's not always practical to implement it for every change or every notification that needs to go through, but certainly we can do it for quite a lot. If we do this, we give timely communications. And by doing that, we improve future decision-making processes. We want to look at how we can use this communication to comply with our legal and regulatory standard requirements. And of course, we have our transition as we go from stage to stage. So we need to include, in part of the transition process, we need to ensure we have a business continuity plan in place. We need to make sure that there are procedures established to carry out that transition from one phase to the next. We need to include our risk management. And then once that transition has taken place, whether it was successful or less successful, we need to update the risk management plan to make it clear. Within our operations, we need to think about our aspirations. So we have our service level agreement, which may be something that's quite well known. But what about our service level objectives? What is it at the highest level that we're actually trying to achieve? And are we making that objectives? Because sometimes we can narrow our focus so much and we are meeting those small objectives, but we're not meeting it at the higher level and understanding why that piece of software is there in the first place. Then our service level indicators, of course, are then being used to help us see, did we keep on track with those objectives that we had? Okay, so that was the general structure of what this standard could talk about. So let's take any one example, and I'm going to take continuous integration as the example. So we're going to look at how procedures and infrastructure should match the deployment environment, because when we're applying it, if we're testing our continuous integration across an environment that does not match where it's going to go into production, well, then we're not truly testing it. We should try to use automation where possible, because if we can automate it, we can speed up the time to develop and time to deploy. We can also ensure consistency throughout. We don't accidentally add something in and forget to apply it for all future builds. Neither do we forget to take something out. Automation can be applied in a range of areas. It can be applied in automating the build itself. Now, the build can be the build of the environment or the build of the individual elements of software. The packaging of it. We can automate the package. We can automate validation. We can automate the verification. And of course, we need to increase our observability into the overall system and into how the package itself is performing. So we want to apply monitoring and auditing. And there is very little, if anything, there that can't be automated. Now, I know that there will always be somebody who says, well, you can't automate your interactions with the interface. And you can, but it never does any harm to have that human in the middle to do that last check. Because although we're building very sophisticated computers, we still don't have that level of where our brain wanders and we pick up something random that was wrong with the system that we didn't know about before or wasn't aware that that was a criteria. That kind of wandering brain is not something that our computers can do very well yet, but we can. So there is certainly a place for human in the middle, but as much as possible, we should try to automate. And even automating our communications, simple notifications that a task has happened, or to record an item, a task as having occurred, and that item is now signed off. Just general communications, in the most part, can be automated. There will always be some that are not. So let's talk about left shift. With left shift, we prepare to continuously integrate to our discussion forums, our internal policies. We need to have our disaster recovery plan and, of course, our business continuity plan. And we need to do our code review. So continuously integrating everything, all of these things need to be prepared so that we can carry out a successful integration. If we try to integrate without having a disaster recovery plan in place, and then the integration doesn't go well, then what do we do next? So we need to plan. We need to be careful and plan for this left shift. It is a new way of thinking. We need to continuously integrate, actually carrying out the task. But as part of carrying out the task, we need to evaluate what our constraints are and evaluate the functionality itself. We need to look at our risk management process and update it. We need to perform our automated processes. And apply our incident management, obviously apply it as we go along. So there's a lot in the small and lower levels as we start to look at this. And then, of course, the observability. While we try to do our integration steps, we need to record the integration. What's happening before we do the integration? Have we got a copy of everything? Do we know and understand the state of the system at that exact moment before we hit the integration? And as we do the integration, what are you integrating? How are you integrating? What else is going on at the time that you're integrating? After you've carried out the integration, was it successful? Did you continue to monitor to make sure that there wasn't an intermittent fault in the system? So monitor, record before, during, and after we carry out that integration process. Whether the integration is successful or not, we should notify the stakeholders of that change. Even if the integration was successful and everything seemed to go well, you need to notify the stakeholders that some new feature is available or that some change has been made. And we've seen the disastrous consequences. We can see that it caused lives to be lost if we don't inform people about an update to software. It's not just the package that we're creating and that we're trying to integrate that we need to monitor and evaluate. We also need to update our configuration management items. We need to understand where they are and make sure that that information is updated. That's part of our knowledge management procedures. Now, how much do we do on that will vary from company to company. But again, a lot of this stuff can be taken from our systems. They're already there. We just need to pull it away. These are very specific examples, taking down from our wide standard into a narrow element of the standard and taking then the specific tasks within that standard that we can say, these are key things that I can do. If we break this down into very small elements, standards can be easily implemented. But it's up to us to choose to implement the standard. So I'd suggest that the takeaways for this particular presentation would be, for each standard, really focus on or concentrate on one small activity of that standard. If any one standard, it doesn't matter what the standard is, but focus on that one small activity. See how you can apply it into your organization to make an improvement in the processes that are there. Try to apply one standard well in a manual way. Try to fix your processes in a manual way before you attempt to automate any process. There's no point in automating a process and then find out it's broken everywhere. Fix it, make sure it runs well, and then automate it. And that will again speed up your processes. In the end, although the beginning is always hard, if you use standards, you will save time. And by saving time, you save money. And in the end of it all, again, you will save heartache because all of these tasks will have recorded the information for you that you need. You will have your policies and procedures in place. And should any legal action come down your way, you can prove that you had carried out the task as you had expected to. Use the standards for your needs. Don't make the standards use you. Thank you for listening to my talk.